So today we'll begin a discussion on new chapter called Principal Stresses under a given loading. Um, uh, this chapter is about application of a Moore circle that we learned, and actually this would combine all the knowledge we have discussed and learned until now, and we're gonna consider structures on the combined loading, and based on the combined loading, we'll determine the uh, strengths will determine the maximum stress of the structure, and think about if the structure is reliable or not by comparing it to allowable stress of the material. So before discussing about this new chapter, let me give you a review of a previous lecture. So in previous lecture, we discovered several topics. First, we discussed about the device called strain rosette. Strain rosette is composed of 3 strain gauge, and the limitation of a strain gauge is it can only measure normal strain. For example, if you have this long aspect ratio strain gauge, they can only measure stress along its longitudinal direction. Okay, but even though we measure only this longitudinal direction strain, what we do is based on the strain transformation equation, we can infer and obtain the shear strain in xy direction. This is x and y coordinate system by considering the normal strain along this 45-degree minus the horizontal and vertical direction normal strains. Okay, so this is the case for when there is a 45-degree angle for the red strain gauge. Even though we don't have this exact 0-degree, 45-degree, and 90-degree arrangement, if we can have three directions that can result in like a three independent linear equations in terms of E x prime, E y prime, and E x prime, then we can also obtain the strain component in xy direction. Okay, so we discussed about it in previous lecture. Okay, and one thing you have to remember is when you have a three independent linear equation, you are guaranteed to find three unknowns, and there is three unknowns, so you can obtain the answer if you have your strain gauge arranged in to have three independent equation. Okay, after that we discussed about the relationship between Moore circle for stress and Moore circle for strain. So what we have learned is that in Moore circle strain analysis and in Moore circle stress analysis, we can obtain the principal axis where we can have zero shear stress, or we can have zero shear strain. By considering the Hooke's law, generalized Hooke's law, we found that when a specific coordinate system satisfies zero shear stress due to the material law, we are guaranteed to have the shear strain components to be zero, and this relationship holds for both direction, forward and backward. Okay, so the conclusion was that principal axis must be same whether we consider stress and strain. Okay, however, even though the principal axes are identical, you have to remember that, for example, if you consider the plane stress problem where one of the principal stress is zero, there is no guarantee that there is one zero strain, if you consider the strain component of it, because the reason is there is Poisson ratio. Even though stress in one direction is zero, due to the loading in the other directions and the Poisson's ratio, you can have non-zero strain in the direction of zero principal stress. And as a last topic of in last lecture, we discussed about strain analysis of plane stress problem, and we actually solved some specific problem where we have 3D Moore circle for stress analysis, where we have plane stress problem, we have zero stress and two non-zero plane principal stress. By converting this into strain Moore circle using the material properties such as Poisson ratio, we found that actually this guy moves to mapped onto the non-zero strain. Okay, so we solved a specific problems with some real numbers and found that actually this problem, our discussion was useful in designing mechanically reliable structure. So today we'll consider even more complex cases combining many different loading, and let's begin the discussion in the next video.